Hello, people. Welcome to another episode of This Dev Life. On this episode, we have Lawrence Agbani. Again, yeah, I know we had him last episode, but hold on, wait. We're introducing a new series, and this series is called Unscripted on This Dev Life. And what we'll be talking about is just stuff around general software development topics are like what the software is, what the class is, what object-oriented programming is, what all sort of stuff are. But of course, that is not what we're talking about today because it's supposed to be unscripted. And who wants to get the topic we're talking about today? It is who can guess? It's monoliths versus microservices architecture. Let's get right to it. Lawrence, thank you for coming on the show.
Thank you. Thank you for having me.
Yeah, so guys, you met Lawrence last week already, but if you haven't, no worries. You can go and listen to that episode of This Dev Life, where he introduced himself and he talked a whole lot about his life as a software developer, what it felt like, starting programming and all sorts. So we have Lawrence on the show. He's a software developer. He works for an e-commerce company in Germany. And we'll just get right into the topic we have to talk about today. So, Lawrence, what is a monolith? What is a microservice? What does all these things mean?
All right. We're supposed to be having this conversation together, right?
Definitely.
Cool. So, yeah. Monolith in terms of how we have it with software engineering is basically seen as an application that is built as like a unit together with everything in it. Um, and I'll try to explain this uh, with a very common example. Um, back in the day, we had radios that had the cassettes,
Mm-hmm.
place where you could put the cassette inside of it, and then the speakers were right next to the cassette door, and then they had the tuner where you could tune for the AM FM stuff. You had the knob there and the antenna, and then they had everything all in one box.
Yeah.
So you just lift that box, and when you get that box, you put the batteries inside. You can put in your cassette. Cassette is going to play. You can switch to AM FM mode, and then you can tune, and then you can do all of that all in one. So pretty much in software, that's what the monolith is. That's everything together in one piece. We have the front end, probably the back end, and everything that has to make the application work as one application, one gigantic application like that. And everything is inside of it,
Just
pretty
like
much.
all the software components bundled together as one,
Bonded together as one, all the
just
parts of the software. They're just one big application.
one big family. All right. Okay.
Extended family.
And so we've talked about what a monolith is. It's all software packages going together, the front end, the back end, maybe even the database, everything it connects with. You can basically just take that whole package and deploy it, and then everything you need to run it is
Everything
inside there.
works.
And then
Mm-hmm.
recently we've been hearing stuff around microservice architecture. Well, not that recently anyway. It's been a couple of years around the block now. Um, where you hear, I'm gonna containerize it, I'm gonna dockerize it, this microservice service-oriented architecture. What does it really mean to a software developer?
Hmm. So service-oriented architecture or maybe microservices as you have or as well, it's just basically an architecture that involves collection of services that communicate with each other just by simple data passing, mostly via APIs, but there are other means, right? So, but then it can involve two or more services communicating with each other to coordinate some activity, basically. So that's just what service-oriented architecture is. So it's architecture that involves collection of services that communicate with each other by simple data passing and could involve one or more of those services and that are basically trying to coordinate some activity.
Okay, so take it for example. Let's say I have an e-commerce application, for example. In a monolith world, I would have my payments, my authentication, my
Mm-hmm.
inventory, my order processing,
Mm-hmm.
everything in one single bundle of
One
application.
application.
Doing the same. So if
Mm-hmm.
services fail, it means payment has failed, all the other components have failed. But while
Exactly.
in a microservice architecture, services
Split all these things
payments
apart.
is in one running on one server, sort of. Uh,
Exactly.
Payments is running in one place. Orders are running in one
Check out.
place. Checkout, authentication, sign up, email services, they are actually running in separate instances of themselves. Is that what it is?
Exactly.
Okay.
Yes, that's what it is.
So now, what
That's
if one
essential.
service now goes down? I'm playing the dumb guy here.
So so yeah, that's the thing. And that's the cool part of microservices. If one service goes down, the application is still alive. The application still runs with other parts of the services that are still working. How do I put this cleanly? I wanted to use a car, but then cars are basically microservices that are monoliths together at the same time. But that's a perfect example. But yeah, if you're running an e-commerce website, for instance, and you have everything together, if there is an overload on checkouts, right, and you don't have proper, maybe you're not properly skilled, and there's an overload on checkout, it's most likely that would basically crash the entire website, and people will be able to access other parts of the website. But the cool part about microservices is if you're having too many people at checkouts, right, it's the checkout service that is suffering. And then you can scale this checkout service differently. So if the checkout service maybe you didn't scale it and dies for some reason or fails, users can still browse the website, they can still add to carts. You understand? Users can still do every other thing that has to do with the application but checkout. And
Okay.
yeah, pretty
But
much.
what if one other service depends on that service that is either down or overloaded? What happens in that scenario?
So if a service depends on that service, the service will most likely respond, but to respond with a failure because, of course, that service that it depends on, it's not really functioning, and that's where the architecture bit comes in. So you have to basically sit down to think about how you're going to architect this app in such a way that you don't have too many dependencies like that. Because the main idea behind microservices is to have the applications to be or the services to be independently deployable by themselves, like they are their own applications, for instance. So you have to look for a way that it can fail. I wanted to fail silently, but that can
No,
also
fail
like be a two-edged
gloriously.
sword.
Fail with
Yeah.
honor.
So you have to look for a way that it feels in such a way that it doesn't interrupt user experience in any way. So like in the e-commerce example, um, the checkout depends on some product data or product information, for instance. So when you go on the checkout will most likely want to fetch product data based on the product that you're viewing in checkout page, etc. Wants to fetch like address data, so it wants to fetch some user information as well. So if all those other services that the checkout service needs to populate um, a checkout response are not available, of course, the checkout will most likely fail, right? So, yeah,
So
and pretty much it.
now when these things happen, so we're talking about failing gloriously. There's this concept I hear about frequently, um, that you can sort of have these things in a queue. So let's say you want to check out and the checkout service is overloaded. So what happens
Mm-hmm.
is those things go in a queue, and then once checkout is available again, those queues just start processing themselves, and that is
Yeah, so yeah, and that works. But the thing is, it works in certain scenarios. You don't want to do the queue thing every time. Like for instance, if a user tries to check out, right, you want to, and that's also a way to solve the problem. Like we have a problem now, the checkout has failed, right? We can solve that problem, but then you want to look at it like, does it make sense at this point to implement the queue system because the checkouts might need to give like instant feedback and then it has to do stuff instantly. And I'm just using that as an instance. Like there are some services or there are some parts of the application that need to do something instantly. But if you believe that eventually, so if the business has sat down, have conversations with developers, and then everybody believes that eventually we're still going to process this order when all this information are available. Like for instance, why I say the checkout will fail is because for the checkout to be able to bring out some information, or to get some information to process that order, it needs product information, it needs some user information as well. And if either of those services are down, it cannot be able to even display that checkout page for the user to work with. So in that case, it will fail. But if we have a problem with maybe the order fulfillment service, if there's something like that, when the user clicks on the checkout, he already has the information, you click on the checkout, we can take all that information from the checkout and put it in a queue, right? And then whenever the order fulfillment service is ready, you can pick up that message or that request and then fulfill it and carry on.
Okay, so
that's where you want to use.
So what we just explained here now are like queuing stuff when a service component is unavailable. Is that some of the pros that microservice architecture has over monolith architecture?
Trust me, I've seen monolith applications that use the queue system as well. So it's not really it's not the microservice advantage. Like it's one of the things you can use to make microservices even more interesting and asynchronous, but you can see monolith applications also using queue systems as well. Because but what I feel like is an advantage for like for monoliths, I believe one of the advantages we have for monoliths, there's an advantage actually, even if everybody wants to make them look bad, they have advantages, they have pros. And one of the pros is that you have faster initial development because you do everything together, right? And then there's little confusion for developers. Developers don't go crazy because when you come into the team, for instance, they're like, see this one repository with all this code, that's all you need. And then you go inside, everything you need is in there. You don't have to be confused as to what this service does, blah, blah, blah. You definitely ask, okay, what does this code do? What does that do? But everything is in one application or one repo, one language, most likely, so you know what you're doing. And it's a one-stop shop code base, basically. But also, that brings us to some certain issues with the approach with the microservices, which is we have multiple services that are most likely handled by different teams and are written in different languages. So you can have that problem where a developer comes into the team. Oh, how do I get this data? You need the checkout service. Oh, the checkout service. How do I get the checkout services from that repo? It's handled by that team. It's written in Ruby. But I'm working on the payment system. Payment service is written in Java. I don't know Ruby. And there you have problems. So yeah, and this developer now cannot be able to quickly jump on that part of the project basically until he maybe knows how to write Ruby or find someone that does and stuff. But yeah, for pros, it's not the queuing thing is not part of the pros of microservices. It's just it just makes it more interesting, but also you can use queues with monolithic applications as well.
So now to just try to sort of sum it up. So you as a developer, as Lawrence is a developer. When and why would you choose a monolith over microservices, and when and why would you choose a microservice over monolith? Just paint those two scenarios for us.
Let's see. So if you have scale in mind, because everybody feels like monolith, microservices is like the silver bullet. It's not. There are cases where it's not a silver bullet. Like there are cases where you actually just need a simple application that runs and it's fine. And for instance, if I'm building a blog, it's like I want to start a blog, and then for the blog, I go and write email notification service, and then I go and write text message service. I go and write, or I start splitting everything to microservices. It makes no sense. Like in that situation, I just need something that works, that I can just go on it and publish content. And that's all. I can write a monolith for that, right? And how much would you want to scale a blog, for instance? You get, of course, you can start having like many visitors, but you have just one particular, most likely just one page that you're filling up with content that users are viewing. So why would you want to scale that in, like why would you want to split that into services? Basically, you wouldn't want to do that. But if I was starting an e-commerce business, right, and I want to build for scale, right, I want to be able to ensure that my application doesn't die. Like I was working for an e-commerce company back in Nigeria where there was this Black Friday thing that happened, and they were selling, I think it was PS4 then, for a very ridiculous amount of money. The whole Nigeria was on that. I want to say the whole Nigeria because the traffic was massive. Many people were on the site that day, and the site crashed. The site crashed multiple times. People were like, they are scammed. They have scammed us. They are finished selling, and they don't. This basically word on the streets. Like they are like they are finished selling us. They are finished selling all the PS4s they have now. They can't sell anymore. So instead of them to say anything,
They
they
just
decided
turned
to
off the
off the website.
websites.
That's what people were saying, But that's not what really happened. It was a monolith as at then, and one part of it broke the entire website, and it was chaos. Like everybody in development were running helter skelter trying to fix stuff. But the thing is, people really won't really get it. So like eventually when the company moved to microservices, all these things were mitigated. So before the Black Friday comes, everybody will be like, okay, you know what? This is basically do like an assessment to know where we are going to be having pain points, like where users fire the most when they are shopping. Okay, when users are shopping, they fire this checkout page very well. Let us scale checkout. So based on metrics on the last Black Friday and what we got,
We're able
scaled
to make that
down.
decision.
Exactly. So now you create a checkout service that's totally agnostic from everything, just basically uses APIs to fetch data. And then the main application just calls the checkout service when the user goes to checkout. And that way, if there is any hit that is going to be gotten, that hit is gotten by the checkout service. So if we have to scale, we just scale the checkout service and everybody will be fine. The entire application still keeps running. So if I was to start an e-commerce business, of course I want to split everything like that, because once the traffic starts coming in, you don't want the entire application to go down and then people on the road start saying that you switched off your website. Exactly, because of something, but they don't know you're actually going through a downtime, So yeah, it's not a silver bullet. You don't want to use microservices to create a blog. What an experiment. Imagine how much time it's going to take, because
except they're actually creating the blogging engine itself where millions of people will come.
Where millions of people, exactly. So you think about it. Do you really need this? That's the first thing you think about, because of course, if I have a blog, I don't need that. It's robust. Microservices are robust. They ensure you can do different things. But once you start getting to very simple scenarios like blogs and all those other tiny websites, it is too much work. It's too much. Like you just stress yourself. So why not just at that point, monolith makes sense. Put everything in one piece and ship it. You'll be happy. Then if you're going to run an e-commerce website that is going to grow at scale, you would want to start thinking microservices so you can be able to have independent applications differently.
And separation of concerns.
Separation of concerns as well. And that way you can add features that don't affect the entire flow of the application. Your deployment lifecycle doesn't get affected as well. You understand? So imagine there's already something on the pipeline that needs to be deployed, a huge application has something in the pipeline that needs to be deployed, and then there's a problem with the email notification. You now have to do a fix and sort of, it depends on how the team structures their deployment pipeline. They might have to just deploy along with that small tiny fix just to have that fix go out. But at that point, they've pushed some very useless code already to production, etc. So, but you can have separate deployment pipelines for different things. So
services.
Exactly. So if the email notification is broken, you can just go there and fix it. Or if you want to add new features to the email notification, you just go there. And then the entire application doesn't know about this. It keeps running, sends that email. Whenever it wants to send an email, talks to the email or the notification service. And then the notification service has some new features. Oh, wow, new features, amazing. But you didn't have to affect like the entire flow of the application.
So now in the microservice architecture thing now, it now comes the concept of, so for example, I have 5 services, 5 microservices that are powering my front end application. And
Mhm.
let's say, for example, checkout is in version 5, and the current service that I actually calling in, maybe the front end is still on version 4. Um, what sort of advice would you give to a team that is trying to adopt microservice architecture to ensure that the front end is using the recent and best version of the services they are calling?
Oh, you mean, okay, so what you're trying to say is if you have a front end that is on a higher version, then you have
So I'm saying,
services that run
so
on
for
it,
example,
or
we
what?
have checkouts, payments, orders, and everything. The checkout team they are the fastest team that writes code. They're on version 5. Payments team is depending on checkout team, but they are actually still using version 3 of checkout. But the best
Hmm.
features are actually on version 5 of checkout. All the fixes they need done, they're on version 5 of checkout, but they are afraid to switch because they don't want to write new code. How do you advise teams to manage that sort of complexity?
Hmm. That's a very that's a very specific scenario. Those things happen actually, but I don't know. In my on my own, well, off the top of my head, um, if the checkout team needs or the payment team needs stuff from the checkout, normally what anybody would do is if you're writing for this set of APIs, because once you start switching versions from maybe version 3 to version 4 and version 5, it's breaking changes, definitely breaking changes,
Mm.
meaning there might be some APIs that are deprecated on version 4 and 5 that are not deprecated on version 3. And if the payment service is using version 3 of the checkout service, the payment service is obviously going to have breaking changes when they move to version 5, right? So in that kind of scenario, you have to write new code. If you're going to try, if you want to use the new features of what, or you want to use the latest and greatest stuff that the checkout team has to offer, you definitely have to change your API, the API calls you're making to what they have. You definitely have to do breaking changes on your end. So that means the payment team too would have to do an upgrade. They have to change things, right? They have to change how they call. They might not change how others call them, so they might not have to change their own version, might not have to update their version, but they might want to change how they call the checkout
The
service.
checkout
Because I
service.
mean, and yeah, and in that kind of scenario, you don't really have so much stress like you wouldn't really have, and that also depends on how much changes have gone over time, and if certain things have been carried on from the previous two versions, right? So again, I don't see a reason why the payment team in a very old version, using a very old version of the checkout service, would want to upgrade if they are not also looking at doing an upgrade themselves. Because you're totally fine with this old version you're using, everything still works, everybody's happy. So the only reason why you want to upgrade is if your own changes or your own business requirements have also changed, and the only way you can adopt or adapt to it is if you have like the latest version of what you're calling from the checkout service or something, and stuff. So at that point you would also want to do your own upgrade, and you would definitely have to write code to do that. So if the payment team would have to make changes made by the checkout team, they would definitely have to do some breaking changes as well, because versioning is when you move from one version to the other, you're definitely breaking something.
Yeah, definitely, definitely. Okay, so you've heard it from the pro. I'm not a pro here. There's the pro.
Oh, he's the pro. I'm just on the back seat.
Tell us on that. Okay, so they say with great power comes great responsibility. When you're going to Microsoft architecture, you're taking on a whole lot of more responsibilities. But of course, if your service needs it to be more productive, to deliver value to your customers, of course, go ahead for it. But for simple scenarios, monoliths are awesome. And of course, I named this monolith versus microservices, but it's not actually a showdown battle between each of them. It's just to lay out what are the benefits of each one of them, and why, when, and where, why should you choose to use which one over which one. And of course, we've been able to explain that on this episode of this Dev Live that I call Unscripted with Lawrence and Bani. Thanks very much for coming on this episode. I know we have one more episode to record. Uh, so, listeners, you will see here from Lawrence in the next episode. Thanks very much for joining. We will see you when we get there.